Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. In this video, I will be making the calculations from the Chapter 21 Transformers Math Handout. The circuit I'm about to work for you now is circuit number 9, where we have one primary and we have two secondary windings. The formula sheet I'm using is the Chapter 21 formula handout, and you can see here I'll begin by calculating the voltage of the secondary, then the current of the secondary, the power of the secondary, and so forth. I'll be leading you through these formulas. And I have my calculations, as you can see, down below. So this is the spreadsheet. I recommend writing out this spreadsheet exactly like this before you start your calculations, and drawing the circuit. That way you can label all the values on the circuit. This is a cutout of the math handout showing you the values I'm getting, my known values that I'm using from number 9 on the math handout. So I begin by, I have a 250 is the number of windings on my primary. I have 250 windings on the secondary number 1 and 50 windings on secondary number 2. So those were given values as well. And I have the resistance, the load resistance number 1 on the first secondary is 2.4 k ohms, and the resistance on the second secondary is 24 ohms. So the first calculation I'm going to make is the voltage of the first secondary. And I'm using the secondary voltage transformer formula. This first formula that you see here, the voltage of the secondary is equal to the number of windings of the secondary over the number of windings of the primary times the voltage of the primary. Now in this case we have two secondaries, so we're going to go through all of those calculations 2 times. So I begin by putting in first the number of windings of my first secondary, 250, over the number of windings of the primary, which is also 250, so this is going to be a 1-to-1, times the voltage of the primary, which is 120 volts. So we'll see that my secondary is also 120 volts because it's a 1-to-1 ratio. The next thing I want to calculate is the current of my secondary. So I'm going to take the voltage of my secondary that I just calculated, 120 volts, and I'm going to put that over the resistance of the first secondary, which is 2.4 k ohms. So the 120 volts is already in my calculator, so I just hit divided by 2.4 times 10 to the third equals engineering, and that tells me 50 milliamps. Alright, the next thing I want to find is the power of the first secondary. So I use this current that I just calculated, IS1, times the VS1 that I calculated right here. So I take the 50 milliamps, it's already in my calculator, times the voltage of the secondary, which is 120 volts, and that gives me 6 watts. PS1 is 6 watts. So let's fill in a few blanks. So I found the voltage of my secondary. I found the current of the first secondary, 50 milliamps. And I found the the power of the first secondary, which is 6 watts, the power of the primary always equals the power of the secondary. So PP1 is going to equal PS1. So I'm going to have 6 watts right here. Now you only have one primary, but you will have 2 powers that are induced into that primary. So we're going to take our first primary, which is 6. We're going to take our second primary when you calculate that here in a minute, and we're going to add those up to get the total primary, because there's 2 primary powers. And you'll see the same thing for current when we get to that step. All right, so now I'm ready to calculate the voltage of my second secondary. So I see here that I have 50 windings this time. So I say 50 over my primary windings right here. So I put in the number of the secondary, number 2, which was 50. Now I'm going to put in the number of the primary windings, which is 250, times the voltage of the primary, which is 120 volts. We see it here and here. And I'm going to get 24 volts on my second secondary. Here. So now we're doing these numbers. All right, so I got the voltage of the second secondary, which is 24 volts. Now I want to find the current of the second secondary. So I'm going to take that VS number 2, which we calculated, 24 volts, and I'm going to divide it by the RL2, which is 24 ohms. So divided by 24, and that gives me 1 amp. So my IS2 is 1 amp. Now I need to find the power of secondary number 2. That would be the amount of power in this winding here. So I take that current that I just calculated, IS2, which will be 1 amp, as I calculated right here, times the 24 volts VS2, because remember, for the power formula, P is equal to I times V, using the power formula right here. Up here we used Ohm's law, V is equal to I times R, to get our current. Once we get our current, we use our power formula. PS2 is equal to IS2 times VS2. The IS2 that we calculated is 1 amp times the voltage of the secondary, which is 24 volts. So that was 1 amp times 24 volts gives me 24 watts right here. So the power of the second induced power in the primary, PP2, is equal to PS2. So both of these are 24, so I can fill in the power of the primary, number 2. The second induced primary is 24 watts. All right, so I'm going to look for the total amount of power in the primary, the PPT, which is equal to PS1 plus PS2. PS1 we calculated to be 6 watts. PS2 we calculated to be 24 watts. 6 watts and 24 watts. I know this says PS1 and this says PP1, but remember, the power of the primary is always equal to the power of the secondary. Therefore, the power of primary 1 is equal to the power of secondary 1. The power of primary 2 is equal to the power of the secondary 2. So we have 6 watts, we have 24 watts, that gives us 30 watts. Now, I'm asking you here for the total current of the primary, the first induced primary current, and the second induced primary current. I want to make sure that you understand not to get that confused with your secondary currents. This 50 milliamps right here is taking place in here. This 1 amp right here is taking place here. But what I'm asking for in this section right here, in these currents, what I'm asking for is what's going on my primary windings. So there's a couple of different ways to get the primary current. One way is I could take my total primary power, which was 30 watts, divided by the voltage of the primary, which was 120 volts. That 30 watts comes from right here. This 120 volts comes from right here. And I could divide that using the power formula. P is equal to I times V, so I would be equal to P over V, giving me 250 milliamps. Now, in order to find IP1, I would take PP1, which we remember was 6 watts right here, divided by VP, 120 volts. So when I take 6 watts divided by 120 volts, that gives me 50 milliamps. And this calculation that I'm making right here, this 50 milliamps, goes in this blank. To find IP2, you take PP2, power of the second induced power in the primary, which was 24 watts right here. And you take the VP, which was 120 volts, and when I divide 24 into 120 volts, that gives me 200 milliamps right here. So notice IP2 is 200 milliamps. So you've got one current induced in the primary, and you have a second current induced in the primary. And those two add up. If you wanted to say another way of finding IPT would be equal to IP1, which we just calculated to be 50, plus IP2, which we just calculated to be 200 milliamps. IP2 would be equal to 250 milliamps. So we found IP2 two different ways. So just make sure you pay attention and understand that IPT, IP1, and IP2 are not the same thing as IS1 and IS2, but your powers are the same. PP1 and PS1 is the same. PP2 and PS2 are the same. And so this is how we calculate a transformer that has one primary and two secondaries. And on this one, we're not going to worry about ZP. We're not going to calculate ZP in this circuit.